Okay, guys, welcome back to grade 9 science in the astronomy unit. Today we're going to be talking about the moons. So the moon, specifically the lunar phases, as well as the phenomena and the occurrence of eclipses. So today's lesson will feature worksheets 3 and 4 as a follow-up. In terms of an exit ticket today, what I would like you guys to do is once you've completed your own version of worksheet 3 and 4, I would just like for you to take a screenshot of your responses to worksheet 3. So just kind of zoom out and take a quick screenshot of worksheet 3. And for worksheet 4, just defining these terms here and just taking a screenshot of that. That is your exit ticket for today. Okay? Today's lesson will also feature another one of those lovely online simulators, which I think do a really good job of explaining the phenomenon. So again, today, you're going to be clicking this link. Now, if your link doesn't work right away because your Flash, for some reason, isn't auto-enabled, which is a common occurrence, it's happening to me as well, then what you can do is you can just go to NAAP Labs, and then today you're going to go to Lunar Phase Simulator, scrolling all the way down to the bottom. It's the second one from the bottom, Lunar Phase Simulator. Seeing my mouse here, you're going to click SWF, click Keep, and once the file loads, you're going to open it, okay, and then you can put it in full screen if you like. Okay, so a little bit about the moon. We know that the moon is the Earth's only, and obviously being the only, it's the largest permanent satellite that we have. So the moon is said to have come into our orbit roughly 4.5 billion years ago when a giant rock the size of maybe Mars even collided with the Earth, and it remained in orbit afterwards. So that's the origin of the moon. One popular theory about the origin of the moon. There's many songs written about the moon. There are many things that the moon can indicate to us, including things like when it's time to harvest. We have the harvest moon. And it's interesting to study this big, massive rock in our sky that for some reason looks different every day that we look at it. So why is that, and what's causing it to look different? Well, that's the lunar phases, the phases of the moon in its orbit around the Earth, as well as in our orbit around the sun, and the direction that we are facing. All of those things play a factor in the appearance of the moon. So this worksheet is designed to help you guys simulate the lunar phases and understand what's happening as we progress through them. So before we start with that, we should define a few terms. So this image on the right here is all of the phases of the moon. So starting at the new moon on the right-hand side, as the moon rotates around our planet, it becomes a waxing crescent. Okay, so at the tiny little sliver, we call those a crescent. Okay, then it gets to about a half full view, and we call that the first quarter. After the first quarter, as it continues to get bigger and bigger, it becomes a waxing gibbous. The waxing gibbous is just about 3/4 size of a full moon. Then halfway through its cycle, we get what's called the full moon. You see it in all of its omnious beauty and full light. After that, it starts to regress again. We call this the waning gibbous. So waxing gibbous is as it's getting bigger still. We have a 3/4 moon. The waning gibbous is as it's starting to get smaller now. We're back to only 3/4. We call that the waning gibbous. Then we have the last quarter, then the waning crescent, and then once again we have the new moon. So why does this happen and how does this happen? Well, let's take a look at our simulator. So it says to move It says to turn on the show time tick marks at the bottom of the page and move the stick figure to midnight. So show time, and let's move him to midnight. Okay. Question number 1 says to select new moon from the moon phase menu. What is a new moon and what causes it? So to select, we have a drop-down menu here of moon phases. We can select third quarter, waning gibbous, full moon. In this case, it asks us to select the new moon. What is a new moon and what causes it? Well, let's take a look. We have our sun directly to the left, and then in the middle of the sun and us here on planet Earth, we have the moon. So what causes it to be a new moon? Well, let's think about our optics knowledge here. So optics, we know that in order for us to view an image, that object has to reflect light towards our eyes, which then needs to make contact with our retina so that it can then send the signal to our brain. Okay, our occipital lobe in our brain tells us that we're seeing, and it creates an image of an object. So if the sunlight comes from behind the moon, can any of it actually reflect off of the face of the moon to us, the viewer, over here?
No.
No, it can't. So what happens with a new moon is because all of the light is behind us, we can't actually see anything. So we get what's called a new moon. We might just see the outline of the moon. Now, when I taught this to the previous section on Friday, I had a lot of sunlight coming in from the blinds behind me, and so they couldn't see me very well. So what I did was I opened the blinds and said, hey, this is kind of the same thing. So if you could imagine yourself sitting in a room, you guys, a lot of you use Snapchat or TikTok, so this might be a relevant example for you. If you can imagine yourself sitting in a room and you've got blinds behind you and you're on Snapchat trying to take a selfie or a video, and you can't see your own face because, well, the sun behind you is too bright. There's not a substantial enough amount of light in front of you. So rather than seeing your face in the Snapchat, you just see a dark outline or a shadow. Or maybe the proper term there is a silhouette of yourself, right? So that silhouette is occurring because of the lack of facial fronting incident rays. And because we don't have face fronting incident rays, we don't have any reflected rays that are presenting your image to the viewer. So that's kind of what's happening with the new moon. We don't have any rays that are bouncing off the near side of the moon, so we don't have any rays reflecting to our eyes where we can see the front of the moon. Does that make sense, everyone? Does anybody have any questions about why we can't see the new moon?
No.
No? Okay. All good? Okay, good. It then asks us to select a full moon. So we can either go through the menu and click full moon, or more interestingly, in my opinion, if we start out with the new moon and we make our way around, how many days are in between the waxing gibbous and the full moon? Well, roughly 14 days, 18 hours until we get 100% illuminated. So the moon is on the opposite side of the sun. So we have new moon where the moon and sun are on the same side. And we have the full moon when the moon and the sun are in opposition. We say the moon and the sun are in opposition. What we mean by that is they're on opposite sides. Okay, they're on opposite sides of each other. So we say that they are in opposition. Please excuse my voice today, guys. I have a raspy throat thing going on. I think it's just, I've been doing a lot of moving of older furniture around and working in the basement renovating. I think it's just a collection of dust and just causing a bit of a sore throat. So don't worry, I'm healthy. Everything's fine. But just wanted to excuse the raspy tone this morning. So the sunlight is able to then reflect off of the near side of the moon, allowing us, the viewer, to see the moon, right? Now, sometimes there are some misconceptions about the new moon and a full moon. I have heard previously theories that, okay, well, this must be what we're seeing here in the simulation. This must be the new moon because, look, the sunlight gets blocked by the planet and then we can't see the moon, right? And that's the theory of an eclipse, right? And that's applying the eclipse theory to the lunar phases, and that would be incorrect, okay? The sunlight can actually reach the moon, the shadow of the Earth, because remember, this distance is not accurately represented. The distance between the Earth and the moon is quite significant still. And in fact, it's actually growing. Every year, I don't know if you guys knew this, a little fun fact about the moon, it's actually getting further and further away from us. I think it's about 3.5 centimeters per year. It moves further and further away from us. So fun fact there. Tony.
What's the reasoning for us seeing the moon during the day, like at noon or something?
That's a good question. So that depends on our location on the planet, right? So where we are on the planet and where the sun is. So if you look here, you see the sun and the moon are in opposition as we move throughout the day, right? You can't see the full moon because the moon doesn't rise until the sun sets, right? So we have sunrise, where the sun comes out. We're at noon. You see the moon is below us there. And as we come towards sunset, the moon is starting to rise, but it doesn't come out until at sunset. So for a full moon, right, we're not going to see that until nighttime. That's when they're in opposition. However, if we go to noon, you'll see there are some phases where the moon is out during the day, right? So you can see it here. From third quarter to new moon, the moon is out. From new moon to first quarter, you can see the moon during the day, right? So let's pause here on waning crescent, okay? As we go around, as our day occurs, sunrise, at sunrise, you can see the moon and the sun. The moon is basically at noon high, right? It's right in the middle of the sky. As we continue towards noon and the sun is in the middle of the sky, our moon starts to set. And as the sun sets, you'll notice you don't see much of the moon during the evenings, during a waning crescent. The moon rises as we near the early morning, just after midnight. And as the sun rises, the moon stays at sunrise. Okay? And you'll notice for different phases, let's go to first quarter. You'll notice for different phases, you will see the moon and the sun moving in parallel. They're moving in the same orbit. So you can see that happening here. During the day, you can see the moon and the sun with the first quarter and the third quarter moon and some of the phases in between. So Tony, that's why you can see it during the day at times. It does depend on our location, and it does depend on the phase that the moon is in.
Okay, thank you.
Yeah. Okay. So, 1 second here, guys. I just have to attend to the dog here. Okay, sorry about that, guys. I had to take care of the dog. All right, so now we know why the moon can appear differently throughout the day and the evening. But what happens with these phases, and why are these phases occurring? Well, if we look at it, the moon is orbiting our planet. We know that much. But how long does that take? Well, look at the total number of days here as we get close. And it's about to reset. 29 days. 29 days and 10 hours. What does it seem like it's almost, roughly?
A month.
Roughly 1 month, right? So roughly 1 month for our moon to orbit our planet. Okay. So you have some questions to answer for this one, mostly just drawing the sketches of the phases and reasoning out some responses. So defining terms, can you see a full moon during the day? Why or why not? Remember, we talked about that one briefly in our simulation today. Is there any phase that you cannot see during the day? And if so, why? So again, using the simulator to answer these questions. So I've answered these for those working asynchronously so that they have them in their OneNote. For you guys, if you could please erase them and then fill in your own responses or just fill in your own responses beside the responses I've given you. That's up to you. You can use this visibility of lunar phases screenshot here if you would like to use that to answer the last question. You can. Worksheet 4, we're going to talk a little bit about eclipses. So eclipses occur when our planet has cast a shadow over the moon. So a lunar eclipse occurs when the moon enters the Earth's shadow. The moon is not directly lit up by the sunlight and usually turns a deep orange color. A solar eclipse occurs when the moon's shadow touches the Earth, blocking the view of the sun from a small region on Earth's surface. So, by coincidence, the moon's shadow on Earth just touches on Earth. So this region of totality is actually very, very small. And you can imagine that that makes sense because the moon, by comparison to the size of the sun, is very small. So a total solar eclipse is quite rare. A total lunar eclipse, less rare. So a total lunar eclipse, the whole moon is in the umbra. Now, when I say umbra, we need to define our terms here. So there are two terms that describe the Earth's shadow, the umbra and the penumbra. So the umbra is the area in which the Earth's shadow is full. It's at its entirety. Then there's an outlying region called the penumbra, where the moon is only partially a shadow. Just had to let the dog in again. So if the moon is in the penumbra, we get what's called a partial lunar eclipse. If the moon is in the umbra, we get a full lunar eclipse. And the same thing can be applied to the moon with respect to a solar eclipse. So when we're experiencing a solar eclipse, the sun and the moon are on the same side of the Earth, and we have this path of totality here, meaning the areas in which that total umbra of the moon will reach and touch Earth. Okay, so when do these things occur? Eclipses occur only when the moon crosses the ecliptic and lines up with the sun and Earth. Most of the year, new moons and full moons do not cause an eclipse because the moon is either above or below the ecliptic, but the moon's orbit appears to wobble up and down as the Earth orbits the sun. Actually, the moon's orbit is always in the same plane, but it's tilted 5 degrees relative to the ecliptic. So as the Earth orbits the sun, the nodes where the moon's orbit crosses the ecliptic slowly change. So we can use this app to view this action, if it works. Okay. So you're going to need to click on mooninc.swf as well. Here we go. There's the simulator. So we can see the moon orbiting our planet, and there's the ecliptic. So I'm going to turn off animate, and I will show you that in real time. So as it crosses the ecliptic, when it comes into view here, you get what is called a ecliptic season. So there it is there. It's tough to kind of get it to cooperate without jumping across, but you get the idea there, guys. You can kind of see it.
Yep.
When it's on the ecliptic and it's directly in the plane of the sun, what we get is a solar eclipse from the moon. Okay, so you can toy around with that simulation, and I think it'll help you understand what's occurring here. So you see, as we rotate, right, that 5-degree tilt, right? So it seems to be wobbling. It's actually in constant orbit, but because of the tilt of the nodes in which the moon orbits our planet, sometimes it crosses the ecliptic. Most of the time, it is not in the ecliptic. Okay. So what do you need to do? You need to define these following terms in your own words, okay? The reason I want you to do it in your own words is because I don't want you to just know what the textbook definitions are. I want you to remember them. I want you to understand what these things mean to you. Then I want you to use this shadow simulator and move the Earth and Moon around to create a solar and a lunar eclipse. So you're gonna do both, a solar and a lunar eclipse. Take screenshots of your two solutions and post them here. That's your exit ticket. Once you've taken those screenshots, take a screenshot of your OneNote and post it. Eclipses can only occur on new or full moons. Why? Only a very few new and full moons have an eclipse. Why? Remember, talk about that ecliptic that we talked about in this simulator. A lunar eclipse is visible from half the Earth when it occurs, but a solar eclipse is visible from only a small area. Again, think about the size of the shadow. Why is it that a lunar eclipse can be visible from half of the Earth? Meanwhile, a solar eclipse, when the moon casts its shadow on the Earth, is only visible from a small region or region of totality. So why is that? Talk about the size of the umbra and the penumbra. A lunar eclipse is visible from half of the Earth. Explain that. A solar eclipse is visible from only one small area. Explain that. Okay, so that's your to-do list for today. Just worksheet 3 and 4. Your exit ticket for today is just take a screenshot of your OneNote to show that you've uploaded those photos. Are there any questions about that, guys?
Where do we upload it to? Is there a submit button or?
Yeah, there will be a submit. Yeah, the submit button will be posted. Any other questions, guys?
Nope.
Okay, guys. So then in that case, you're free to get started and work away at this.
Bye.
Okay. All right, guys.
Thank you, Mr. Gate.
See you guys.
Yeah, Mr. Gate.
Thanks.
Yeah. Bye, guys. Dylan, you all good?